Hello everyone. So in today's video, we'll see JEE 2024 January 30 Shift 1. So I have received around 14 questions from my students. So let's start. So the first question is two rings of equal radius are arranged perpendicular to each other with common center at C carrying equal current I. Find the magnetic field at the center. Standard question, right? So we have given two rings which are perpendicular to each other with the common center. Something like this, right? So there are two rings which are perpendicular to each other. This is the common center. Let us say the current in this ring is I in this direction. So due to this current, I can say the magnetic field will be in the right direction. Let us say this is B1. And due to the other current, let us say in this ring, the current is in this direction. So the magnetic field will be in the upward direction. So this is B2. Now the resultant of these two fields will be the net field at the center. So let me show it like this. So that is the net field. B nets. So what is B1? So B1 and B2 both will be having the same magnitude. It will be mu naught I by 2R, right? So that is the magnetic field, and B net, which is nothing but the vector addition of B1 and B2, and B2 is also having the same magnitude because we have identical rings. So this will be root 2 times mu naught I by 2R, which is mu naught I by root 2R. So option 4 is the answer, right? Now let us see the next question. Find the acceleration of 2 kg block shown in the diagram. So this is the 2 kg block which is placed on a smooth inclined plane, and it is connected with a string, and the other end of this string is connected with the ceiling. Let us say this is the ceiling, and there is a movable pulley, and the center of the movable pulley is connected with a 4 kg block. Now here the pulley is moving. So if center is going down with an acceleration a, this end is at rest, you can say that its acceleration will be 0. So if I consider this point, say this point is b, so acceleration of b plus acceleration, say this point is a, by 2 will be the acceleration of the center of the pulley. So a is 0. So we can say acceleration of point b will be twice of the acceleration of the center of the pulley. So if 4 kg block is going down with an acceleration of a, then this 2 kg block will go up with an acceleration 2a. So if I draw free body diagram, let us say in this string the tension is T, here the tension is T, here the tension is T. So in this string the tension will be 2T, right? For the equilibrium of the pulley. So if I draw free body diagram of 4 kg, so there is a 2T tension acting in the upward direction. There is a gravitational force. I'm taking G as 10. 40 Newton is acting in the downward direction. Acceleration is A. So we can say 40 minus 2T will be equals to 4 times A. And if we draw a free body diagram of 2 kg, so there is a tension T in this direction. There is a weight component which is 20, and this angle, let us say this angle is given as 30 degree, right? So that is not provided by the student. So it will be, let's say if it is 30 degrees, so this will become, let me take it as 37, right? So to make the calculation easier. So it will be cos sine 37 degree, and there will be, and it is having an acceleration up the incline 2a. So we can say T minus 20 sine 37 degree will be equals to mass times the acceleration, that is 2a. So from here tension will be 4a plus 20 times sine 37 is 0.6. So this will be 4a plus 12, right? So what we can do, and this can be written as 20 minus t equals to 2a. So if we eliminate tension, so this is the first equation, this is the second equation. If we add first and second, so we will get 20 as 6a plus 12. So a comes out to be 8 by 6. So that will be 4 by 3. If this angle is 37, then the answer will be 4 by 3. So that is the acceleration of 4 kg block. If I multiply this with 2, we'll get the acceleration of 2 kg block, which will be 8 by 3 meter per second square. Now let us move to the next question. The ratio of the kinetic energy and the potential energy in fifth excited state of the hydrogen atom. A very basic question. By Bohr's model, we have derived the formula of kinetic energy, which is 13.6 z square by n square for any isoelectronic species, and the potential energy is given by minus 27.2 z square by n square. Now, if you take the ratios of these, so you can say n square will get cancelled out. So even whether it is fifth excited state or sixth excited state, the ratio will not change. So it will be 13.6 divided by minus 27.2. So it will be minus 1 by 2. So minus 1 by 2 should be the answer. Next, we have to find the potential difference across 700 ohms resistor, and we have 3 resistors connected in series. A very standard question. So this is nothing but 3500, and we can find the current, right? Or if we want to find the potential across this, okay, let us first find the current. So current will be V divided by the total resistance. So that will be 3500 plus 200 plus 700. So that comes out to be 7 by, this is 9. So 4400, right? So that is the current. So the potential drop across the 700 ohm resistor will be current multiplied with the resistance, that is 700. So from here, it comes out to be 49 by 44 volts. So that is the answer. Okay, let us move to the next question. The electrostatic potential due to a dipole varies with the distance r as. Okay, right. So if we have given a dipole, say this is dipole, and say we want to find the electrostatic potential at this point P, and this angle is theta, and this position vector is r. So we know that the potential is given by kp cos theta by r square, or in vector notation, we can write this as p dot r cap divided by r square, or it can be written as p dot r vector divided by r cube. So if you look at this, we can clearly see that it depends, it is inversely proportional to square of the distance from the center of the dipole. So the answer should be 1 by r square, right? Next, find the threshold wavelength if the work function is 3 electron volts. So work function is given to us, and we need to find the wavelength. So work function is electron volts, so we can find wavelength in angstrom by using this relation. E is equals to 12420 divided by wavelength in angstrom if this is in electron volt, right? So it is given as 3, and this is 12420, and we have lambda in angstrom. So lambda will be 12420 divided by 3. So this will be 4140 angstrom, right? Or 414 nanometer. Okay, so again, very basic question. Next, a breakdown voltage of Zener diode is 10 volts. Find the current through the Zener diode. Okay, right. So we have given the potential drop across the Zener is 10 volts. So since Zener and this load both are connected in parallel, so the potential drop across this load resistance will also be 10 volts. So if we know the potential difference across the load and the resistance, we can find the current. So let us say this is IL, and IL will be 10 by 10 kilos, so which is nothing but 1 milliampere. Okay, so if 10 volt is across the Zener diode, and the battery is having 20 volts EMF, then across this 5 kilo ohms resistor, the potential drop will be again 10 volts, right? So we can find the input current, that will be V by R, so which is 2 milliampere. So if 2 milliampere is going in this direction and 1 milliampere is going through the load, then we can say 1 milliampere will pass through the diode by junction law. So answer will be 1 milliampere, right? So that is the answer. So if length of wire is doubled and cross-sectional area is halved, what will be its Young's modulus? Very, very basic questions, because Young's modulus does not depends upon the dimension. It only depends upon the material. So the answer will be, it will not change. So if it is Y initially, it will remain Y, right? Okay, at what temperature RMS of hydrogen gas is equals to the RMS of oxygen molecule at 47 degrees Celsius? Formula based question, we know that V RMS is given by root of 3RT by M naught, where M naught is the molar mass. So if, and this is constant, 3R is constant for both the gases. So we can say, and if their RMS velocities are same, then we can say root T1 M1 will be equals to root of T2 M2. So if I square this, so T1 by M1 will be T2 by M2. So T1, let us say T1 is for hydrogen, and molar mass I can take it as 2 grams, and T2 is given as 47 degrees Celsius, so it will become 320 divided by molar mass of oxygen, so that will be 32. So this will be 16, so answer comes out to be 20 Kelvin. So 20 Kelvin is the answer. Next, if power factor of E equals to 25 sine 1000 T is 1 by root 2, then power factor of E equals to 20 sine 2000 T will be. And we have given that it is a RL circuit. So if it is an RL circuit and the power factor is 1 by root 2, we know that power factor, which is cos phi, is given as R by Z, or I can say tan phi can be written as tan phi will be perpendicular. So that will be, you can say in this case, it will be XL by R, right? R by Z, yes. So XL by R. So in this case, it will be 1 by root 2. So this is given as 1 by root 2, right? So if cos phi is 1 by root 2, we can say tan phi will be 1. So XL is nothing but R, right? XL is equals to R. Now, for this particular source, we have changed the frequency. Earlier it was 1000, now it has become 2000. Now, and resistance will remain same. So if I take it as tan phi prime, so it will be XL prime by R. Now in this case, XL prime will be what? So XL is omega L. If we double the omega, XL will also get doubled. So it will become 2, right? So tan phi prime will become 2. So from here, we can find cos phi prime. So that will be 1 by root 5. So 1 by root 5 is the new power factor when we double the frequency. Okay, right. Now let us see the next question. In a convex lens, the distance between object and image is 45 centimeter and the magnification produced by the lens is 2. Then what would be the focal length of the lens? And we have given that it is a real image. So if it is a real image and this is a convex lens, so let us, this is the object, and here we are getting a double image, right? So it's a real and inverted image, so magnification will be -2. If magnification is -2, we know that it is equals to V by U, where this is, let us say, X and this is V. So I can say U is nothing but minus X, right? So from here, -2 is equals to V upon minus X. And we have given 45 centimeter is the distance between the object and the image. So V plus X is given as 45 centimeter. Okay, so right. So if I subtract on both side by 1, so -2 minus 1 is equals to minus of V plus X minus 1, plus 1, right? So this will become minus V plus X by X, and this will be -3. Now V plus X is 45, so X will be 15 centimeters. So if X is 15, and then what is V? So V comes out to be 15 times 2, so that will be 30. So from here, if you apply lens formula, so 1 by V minus 1 by U is equals to 1 by F. So V is 30 and U is minus 15. So 1 by F. So this comes out to be 30 is the LCM. So 1 plus 2. So this will be 1 by 10. So focal length comes out to be 10 centimeter, right? Okay. So it can be solved under 1 minute. A ball is dropped from the height of 10 meters. After collision with the earth, it rises back to the height of 5 meter. Then what shall be the impulse on the ball by the earth's surface if mass of the ball is 100 grams? So this is the surface of the earth. So just before collision, the velocity is root of 2g10. And after collision, the velocity becomes root of 2g5. So the impulse is nothing but the change in momentum, right? So 0.1 is the mass, and the change in momentum, we can say it will be root of 2g10 minus root of 2g5. So this comes out to be 200 root 200 minus root 100. So it will be 1 root 2 minus 1. So it will be 0.414 kilogram meter per second, right? So that should be the impulse, right? 0.414, or even if this answer is given, that is the answer, root 2 minus 1. Right, now let us see the next question. If a particle of mass m is projected at an angle which is less than 30 degree with initial velocity u, then what will be the angular momentum about the point of projection of the point of projection? Okay, right. I think something is misprinted here. So at let us take it as point of projection, right? Point of projection. So we are projecting a particle with a angle as theta. And at the maximum height, the velocity will become u cos theta, right? U cos theta. And we have to find the angular momentum about the point of projection. So the line of application, line of actions, or you can say the line about which the velocity is lined. So this line, its perpendicular distance from the point of projection will be nothing but h max, right? And the angular momentum is into the plane. So if I want to find the magnitude, it will be h max times mass times u cos theta. Now h max will be u square sine square theta by 2g. So mu cos theta. So this will be u cube m by 2g and sine square theta cos theta. Suppose if this theta is given as 30, then if we substitute, if theta is 30, right, then we can substitute the value of theta and we'll get the answer. And it is into the plane, right? Okay, right. So if you see the paper again, this shift is quite easy. So whatever questions which I have solved, we can solve those questions under 1 minute. So you can easily score around 70 to 80 marks in this paper. So wish you very all the best for your attempt.